Not only does the derivative give you the slope of the tangent line of a function, but it also tells you the rate of change of that function at any point. Slope is a rate of change. Now, in this problem here, concert tickets went on sale at noon and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function, L, from 0 to 9 hours. Values of L at various times t are shown in this table above, where here we have t hours from 0 through 9, and here the number of people waiting in line at that particular hour. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at around t equals 5.5. Show the computations that lead to your answer and indicate units of measure. Well, since we're finding the rate of change of L, we are actually finding L prime of t. L prime of t is the derivative of L, and the derivative is the rate of change. Now, of course, we are asked to estimate the rate of change because we don't actually have a function for L. Instead, we have different values for what L is at different times t. So let's consider this for a second. The derivative is the slope of the tangent line of L. Well, let's take a look at some sort of L. Let's say L looks something like this. And we want to look at, for example, t equals 5.5. Well, rather than finding the tangent line at t equals 5.5, which is impossible because we don't actually have a function for L, what we can do is we can approximate this tangent line by taking the slope of 2 points around 5.5. For example, if you look at this chart, 5.5 is in between 4 and 7. So let's say here's 4 right here, and here is 7. The slope of this tangent line at 5.5 is L prime of 5.5. That's what L prime of 5.5 represents. However, we can approximate this by looking at the slope of a tangent line around 5.5, like for example between 4 and 7. Now, of course, this isn't perfect. However, it's not going to be because we are estimating that rate. So what we can do is we can find 2 points around 5.5 and find the slope between those 2 points. So let's do that right now. So L prime of t, we're not really looking at L prime of t, instead we're looking at L prime of 5.5. So L prime of 5.5 is approximated by the slope between t equals 4 and t equals 7. That's L of 7 minus L of 4 over 7 minus 4. This is the slope between t equals 4 and t equals 7. F of 7 minus f of 4 over 7 minus 4. This is 150 minus 126 over 7 minus 4. 150 minus 126 is 24. 7 minus 4 is 3, and 24 divided by 3 is 8. Now let's take a look at our units. Since we have a slope, L is in terms of people. And our denominator, which is time, is in terms of hours. So this is people per hour. So let's consider what this means. This means that at time 5.5, about 8 people per hour are entering the line. If this slope was negative, that means that if it was negative 8 people per hour, that means that 8 people per hour are leaving the line, they're entering. So we have plus 8 people per hour are being added to our line. So 8 people are being added per hour at this particular moment. And that is what the derivative means. It is the rate of change of some function. Here it's L.